All right, based on our understanding of the previous one, which we did earlier, we'll be able to derive the Henderson-Hasselbalch equation for a base that undergoes a reaction. Are you getting it now? Now, what actually happens in this reaction is that the base actually donates a proton. So the base is acting as an acid in this case. Are you getting it? So if you look at this very well, you agree with me that this is like the acid because it donates a proton to this, right? Why this is the base. So let us use the idea of Henderson-Hasselbalch equation to solve for this one and see what it will give to us. So what do we have there? We have BH positive plus H2O. This gives us B plus H3O positive. And then we say we should use the Henderson-Hasselbalch equation to solve this. According to what I told you that this reaction is what? Reversible. We need to look for their equilibrium constant expression using the law of mass action that states that Ka will be equals to only aqueous solution and gas can show here, right? Water is liquid, it cannot show. This is aqueous also. Water is liquid. So that at the end of the day, what you are going to have will be B, according to what I told you, that the reactant, the product side will always come first. Then H3O positive, right? Divided by what? BH positive. Recall that this H2O will not show. Now, at the end of the day, what do you think we are going to have now? Ka will be equal to... Now, let's look at this together and see what it gives to us. Told you that you are going to make H3O plus subject of formula. So this will be Ka BH3 positive is equals to B and then H3O positive. I like to actually make this H3O stand on this side anyway, but whichever way. To get that one, what do you do? Divide both sides by what? By B. So that at the end of the day, B will cancel B. Alright? And then we are going to have H3O positive will be equals to Ka. Then you have BH3 positive divided by B. Now, what do you think we cannot do? Told you at this stage, what you do, multiply both sides by minus log, right? So multiply both sides by minus log. Here become minus log H3O positive is equals to minus log. Now, told you that this one, you put a very big bracket. You can put Ka times BH positive all over B. All right. Now, I told you that this log, if it's opening through, according to mathematics, it becomes log this plus log that. We will have minus log H3O positive is equals to minus log. First of all, before the minus, first of all have log Ka plus log BH positive divided by B. Right? Now, at the end of the day, use this minus to open through, which is minus log H3O positive is equals to minus log Ka. This one multiplied by this becomes minus log BH positive divided by B. Now, at this point in time, what do you think we can actually do now? recall that I told you that this whole expression here is still the same thing as what? pH. Now, this will be equals to this whole expression here is still the same thing as what? It's still the same thing as pKa. Then we'll have minus log BH plus all over B. And by what I gave to you earlier, if this B must come up, just notice that if this B must come up and this one come down, the sign will change to positive. So your pH will be equals to pKa plus, you don't need to do all those mathematics. Just know that when this one is coming up, this one is coming down, this sign changes to positive. So we'll have log B all over BH plus. So for base, it's usually log of the unionized divided by what? The ionized form. Is that okay? Log of the unionized divided by the ionized form. This is for the base. And that is why our equations for finding ionized and unionized for base are always different from those of what? Acid, just by varying where pKa and pH should be. All right, so let's solve this question. Now, note something. They may want to do something in the exam. This is very, very crucial. Please take note. They may want to do something in the exam by giving, okay, this of B may not really work. This of BH plus may not really work. But they may want to do something for that of the acid. Here is that of the acid. They may want to do something for that of the acid and put, let me come back, and give you something like this. That of the B, they may also give it to you that way. You have to just be very careful. It's still the same thing. Now, that of the acid, they may just give you as HA is equals to H plus A minus. It's still the same thing you are going to do. Just that anywhere you see this H3O plus, what you are now having there is what? H plus. Is that okay? So in this case now, wherever you see this H3O plus, what are you going to have here? H plus. Here, what are you going to have? H plus, right? That is the only difference. So in this case now, what are you making subject to the formula? H plus. You know what acid is? Negative logarithm of hydrogen ion concentration or hydrozonium ion. This one is the hydrogen ion. This one is the hydrozonium ion. So wherever you are going, just note that you must always use what? Wherever you see H3O, you always use what? H plus. Is that okay? So this final one will now be minus log H plus. This is still the same thing as what? Hydrozonium ion. And then at the end of the day, this is still the same thing as what? pH. Are you getting it now? So where you see this H plus, you can also say is what? pH. So please take note. They may also want to do exactly the same thing for the base. Let me try and get one of these questions. They may want to do exactly the same thing for the base by giving you okay. Let's just leave it like that. All right. First of all, you know this base, what actually led to this BH plus is that this base here, B plus H plus, is protonated. Now, when this is protonated, when you say protonated, it means you add hydrogen ion. This will give us what? BH plus. This BH plus now is now what we react with water to form this. So take note of all those silent points. All right, so we've been able to prove that. Now, the next question is, dicoumarol, a naturally occurring anticoagulant. Know what dicumarol is? An anticoagulant, synonymous to heparin, warfarin, and so. That interfere with metabolism of what? Vitamin K. What is vitamin K? If you have read your vitamins very well, you know vitamin K is what? For blood clotting. Aid in blood clotting. So dicumarol is anticoagulant, prevent blood clotting. So both of them interfere with each other. That's why they say you should not give warfarin or heparin with what? Vitamin K. Has a pKa value of 4.4 and 8.0. What percentages of this drug will be ionized? Will be in the ionized. Now look at this question. This question is 2-in-1 question. The first, they say what percent or percentages of the drug will be in the ionized form at pH 6.4. They gave you the 2 pH 6 point what? The pH they gave to you was what? 6.4, right? But the pKa they gave to you, they gave you 2 pKa. One is what? 4.4. Why the other pKa is what? 8.0. Now we say when pKa is tending towards 8.0, what do we mean? It means that the something is what? Basic. It's becoming basic, abi? Why if it's at 4.4 is what? Acidic. Why this one is what? Basic, right? Exactly. So what we are going to do now is we use, for this pKa 4.4, we use what? Acidic to solve. Why for this one we use what? Basic. Is that okay? Now, let's solve. For percentage ionized, for acidic, it will be what? Percentage ionized for acidic to be, the formula is what? 100, 1 plus what? 10 pKa minus what? pH. Abi? Good. So, percentage ionized in this case now would be 100 divided by 1 plus 10 raised to the power of pKa. Here was given for the first one. We are talking about that of the acid now. That is what we are solving. pKa will be how many? 4.4 minus 6.4, which is the pH. pH given is 6.4. The pH is the pH of the body fluid, or the part of the body that you actually want to ascertain the ionization. So percentage ionized will be 100 divided by 1 plus 10 raised to the power. 4.4 minus 6.4, what would that give to us? 2.0, which is 100, okay, minus 2.0, which is 100. 10 raised to the power, this will give us 0.01, right? I think so. 10 raised to the power of minus 2. 0.01 plus 1, you're 1.01. So percentage ionized will be 100 divided by 1.01. 100 divided by 1.01, what would that give to us? 99.009. If you have gotten the percentage ionized, it's not easy for you to get the unionized. What do you do to get percentage unionized? What do you do? Subtract 100 from this, abi? Minus 99.09, which will give us what? Minus 100, 0.99. Or you can still use the formula, which should be the reverse, pH minus what? pKa. So this is for the first one. Now for the second one, you have pKa 8.0, but it is in the basic medium. Is that okay? This one is in the basic medium. So how do we solve? For basic medium, we said for basic, percentage ionized is usually 100 divided by 1 plus what? 10 raised to the power of what? pH minus what? pKa, the opposite. So percentage ionized will be 100 divided by 1 plus 10 raised to the power of 6.4, which is the pH, minus pKa 8.0. Is that okay? Now, at the end of the day, what do you think we are going to have? Percentage ionized will be equals to 100 in the basic medium, 1 plus 10 raised to the power of minus 2.6. I mean minus 1.6, right? Also minus 1.6. Abi? Yes. 6.4 minus 8.0. 1.6. So this will be 10 raised to the power of minus 1.6, which is 0.025. So percentage ionized now will be 100. 0.025, 1 plus 0.0251. So 100, you must be very careful of approximation here. 1.0251. So 100 divided by 1.0251 be 97.55%. All right, 7.55%. So this is the percentage ionized in basic at the pKa of what? 8.0. Are you getting it? At pKa of 4.4, it ionized 99.99, 99 point something. While at 8.0, it ionized at 97.55. So you see that as the pKa increases, the percentage ionization is also what? Increases. Decreasing rather. Is that okay? So that is that for this part of the material. I think that's all.